We're live. It's 11:51. I had to rush to get this in to actually have it qualify as the morning motivation because it's almost noon. Then it would have been the afternoon motivation. But either way, it's still motivation. So it's the weekend. It's a beautiful day outside. And because it's nice here, therefore that means, according to everybody, that it must be the same everywhere else, right? So whatever happens here, it has to be doing the same thing everywhere else. Whatever's happening in my world, that means it's doing the same thing everywhere else. But that means it's weekend and it's time to go out and get something done on your project. So let me know, make a list. What are you guys working on? If anybody's working on anything cool today, or even if it's not cool, because most of the things that we work on are not always super cool. But let me know what you're working on, and we will sound off. And also, the guys that will be watching this, make sure to take a look at the video that I just posted. You guys may have not seen it, may not have gotten a notification on it yet, but make sure to like, share, subscribe, ring the bell so you get notified. But the video that I just posted is one camshaft run on all these different configurations on a Ford. So we ran it with an 306, we ran it with a stroker, both NA motors. We ran it with nitrous. We ran it with a centrifugal blower. I've also run that with a roots blower and a twin screw blower. It works the same on both of those, and ran it with a turbo. Once again, I'm just trying to cement this in people's mind, cement the idea that you don't have to have a dedicated camshaft that it will work. You can also run it with those kinds of camshafts if that's what you want to do. But know that the camshaft that you have will work with all these things. Whatever camshaft you have, I will do IZs, closies, and I don't even have to see what the specs are. You don't have to tell me. I can guarantee you that what you have will work with nitrous. It will work with a centrifugal blower. It will work with a turbo. It will work with a stroker. It will work, obviously, with with a normal kind of NA stocker modified motor. There are other things you have to consider, like having enough valve spring and piston to valve clearance and all those things. But you should be picking your camshaft for what you want the cam to do, irrespective of these other things, for the vast majority of us. If you're building a pro mod motor or that kind of crazy thing, as I said, then we can talk about getting a dedicated combination for that. But, and we saw this also in the big block thing, that we ran this gigantic camshaft, not gigantic in the pro mod sense of it, but gigantic for any kind of a street motor. And yet it still did all the things. It worked with all of those on the big block. This camshaft is 274, which is, I promote a lot, but because I've used it a whole bunch. But if you would pick a smaller 264 or 258 or whatever the 250 numbers that they have, a 246, a 282, all of those would work well. The other camshaft that I recommend a lot for the Ford stuff is that 236 camshaft, because it's 236, 248, it's pretty healthy sized. For stroker applications, it's got a good bit more lift in it, makes more power. It doesn't idle as well. It's shifting the curve higher up. But that camshaft also works. I've run those with blowers and turbos and all that stuff, and that thing works as well. They all do that, and that's the thing I'm trying to get people to understand. And the more videos that I do on this, I'm hoping people will come around and go, hey, look, it looks like that I can run this. So when you're asking a question, can I run this camshaft with whatever thing you're asking about, the answer is almost always going to be yes. Yes, it will work. And then stop trying to hone in on, is this the best cam or is this the perfect cam? It's not going to be that. No matter what you pick, it's not going to be that. It's not going to be the absolute ultimate thing. Don't put that in your psyche that you need to be able to tell your buddies or go online, I picked the best cam for this. No, you didn't. No matter what you picked, it isn't the best cam for that. So get that out of your mind. Just pick one that works and then be happy with that. Because if you're missing the big picture here. If you pick a camshaft and then you're adding nitrous or a supercharger or a turbo, that's the good thing. That's the big thing. That's the big picture thing. You will be very happy with doing that. This thing down here is not going to dictate whether or not you're happy. The boost in the nitrous is going to dictate whether or not you're happy. So focus on the important things. Focus on the important things in life. Today, also, in addition to that, so make sure to go watch that video. But today, and tell me what kind of projects you're working on. But I want you to look at the thumbnail. And the thumbnail is, I took a factory truck intake manifold and sacrificed one for the goodness of education and used a bandsaw and cut it in half so that people could see. I did this when I did the nitrous distribution test, so people could see kind of the tortured path that the error has to take and then therefore the nitrous, and more importantly in that case the fuel. And so it has to go in and make a left into a common plenum, and then from there find its way into all the runners, some of which are shrouded by the inlet tube and then the one-sided opening. It doesn't even go straight into a common plenum. It goes in, and there's a basically a rear wall, and then it has to go up and over to one side to the opening that's in that, and then there is the common plenum, and then all the runners end up in the common plenum. The back ones are not shrouded by that as much, although there is another little alcove, and that's the thing that I want to talk about today. Not so much the distribution or the airflow thing. We've been over that a few times. But if you take a look at what is at the end of where the air comes in before it makes the left-hand turn, there's another little opening. Well, the air doesn't go into there. I mean, there is a small opening at the end of that, what would be the inlet tube. There is a small end opening in there, an opening, but air doesn't flow in there because there's nowhere for it to go. So this is just basically a cavity with an opening in it. So my question is, and there will be multiple ones. In fact, this is going to be our poll while we're talking about this. So does that opening, the alcove, the little cavity with the opening in it, does that improve power? So let's see what people think about that. But we'll talk about that. And the reason that I want to talk about that really has nothing to do with power. I'm curious that if you think whether or not it does do anything. But the reason that I want to talk about it is because I want to talk about how smart the engineers that design stuff at the OEM level. I get this all the time with people, especially people that are making aftermarket parts. Some of the guys that I talk to are really, really sharp, and they understand the reality of the situation. So the reality of the situation is aftermarket guys that are doing something to improve the performance over a factory thing don't think that they're better than the factory engineers. They realize that what they're doing is a very narrowly focused goal. Like if you take a stock motor and you design a camshaft to improve the power, almost anybody in the world can do that. I can do that with my eyes closed. All you have to do is pick bigger duration numbers than the stock ones, and you will make more power. So that bar isn't set very high, not because the OEM engineers, that's all that they knew and they don't know any better. Trust me, they know better. If they wanted to build, you aren't going to beat a factory race team if they decide to apply factory race engineers to making race cars, assuming that that's what they studied. Now, most of them didn't study that, and they studied the things that they're applying themselves to, which are other things. So that's the key element here, is that when they're designing a motor for a particular application, truck, Camaro, Corvette, whatever it is, they're designing it with a given set of parameters that have nothing to do with power. Power is one thing on the list. The peak power and peak torque are probably all but irrelevant, but I'm sure that the marketing people made them have some sort of thing. Hey, we have to have this because we suspect that the competition is going to have this when these come out, because all these are developed ahead of time. So we suspect that this is what the competition is going to be doing. We need to have at least this much, and we have these performance parameters that we would like to meet for, acceleration and top speed and all that stuff. So that's the power part of it. That's all. That's very, very easy. Everybody there or nobody there has a problem achieving that goal. That's actually very, very easy. The problematic part of it comes from, okay, we want you to do that, and then you also have to do simultaneously all these other things. So it has to meet these newly tightening emission standards. It has to meet these newly tightening fuel mileage standards. It has to be able to, because there's going to be knuckleheads driving this, it has to be able to lug down at 1,000 RPM in 6th gear if it's a manual transmission, because guys are going to do that and they're going to stab the throttle, and it has to be able to do all that. It has to have a good idle quality. The list of things that they have to do are tremendous. And so not only does it have to make power, it has to do all these other things. an aftermarket guy that's designing something, an intake manifold or a cylinder head, or especially because he is not inventing something. An innovation is a whole lot easier than invention. So if you take something and you're trying to make it better, that's much easier than you being the first guy that came up with something. A guy that innovates something it's great, and we like that we improve technology as we go. But the guy that invented it is really the guy. So the guy that came up with the LS engine design, kudos to that person. That's awesome. And then as they evolve it and made it in from an LS1 into an LS2 and an LS3 and an LS7 and did all these things that are better, and then left us with hundreds and hundreds of thousands of these things in wrecking yard so that we can all go do our thing. It's important. And all of this tangent level of talking brings us back to this intake manifold. So what do you guys think this little alcove is on the backside, on the end of the air entry for the intake manifold? The poll is, do you think that it adds power? But if it does, or if it doesn't, what do you think that it does? What do you think that they have that there for? And this is another indication and a perfect example of the things that they are thinking about, that they have to think about when they're doing intake manifold designs that have nothing to do with airflow and power curves and power production and that kind of stuff. So it's let me know what you guys think is going on there, because it's interesting stuff. So, oh yeah, and I forgot, Dan. That's probably the most important thing. Is you brought up a good point. Is that on this list of all of these things, of all of these goals that they have to meet? Oh, here you have to do all this. Okay, no problem. And you have to do it for like 13 cents. What? Yeah, you have to do it for next to nothing. So we're going to give you all these demands and not give you any ammunition with which to work. And so ready, now, go. And nope, you have to trim this, you have to trim this, you have to trim this. But this is helping us achieve all these things. Yeah, we don't care so much about the achieving things. You have to do that. That's like set in stone. But you also have to do it for next to nothing, which is oftentimes the big problem. So Robert, David, hello, working on a hospital gurney. Are you like welding it up? The guys at the car farm do that. Brian did welding on stuff for like accessories that I think that they put on wheelchairs and stuff. So it's kind of cool. Saturday, we're getting ready to take Milo for another hike. Maybe another squirrel will run into his mouth. Cool car, not a cool job. Suspension work, wheel bearings on the Spirit. Okay, my least favorite thing to do. That's a little bit of an involved task on that vehicle, isn't it? I think I remember Ben telling me about that. Just watch Stapleton's Ed Pink video. Very cool. And what cam is the best today won't be the best tomorrow, next year. That's the same thing. I mean, we constantly have evolutions. And I think more than just evolution of making one cam better than the other, we just have popularity things. I mean, hey, this is the new flavor of the month kind of thing. And then somebody else will come up with something, and it must have been hard to cut this. This intake manifold cut very easy. It's basically polymer composite plastic, and so the bandsaw just went right through it. I think it's for sound dampening sort of thing. How the intake tube on a Tahoe is different than a Silverado. OEMs have to worry about a lot of MVH. Yes, they do. It dampens induction sound. It's all about the bottom dollar. I think I'd save a penny. Well, you can. I mean, and you have to understand the business part of it too. I mean, they are in business. It is a business. So with any business, if you're selling 1 million of something and you can save $1 on it, that stuff starts to add up. Could boost torque at a narrow RPM range, but I guess it probably to cancel out some kind of intake noise. Picked up my crankshaft from the balance shop, and I can finally assemble my rotating assembly 393 Windsor. That will be a good one. Why, when you add cold air intake, can you hear it more? Emissions, cost, efficiency. Some cut the top of those truck intakes to port them. Wonder where they slice it to do that. There's not really very much wall thickness there. Of a factory drop-in K&N washable filter, there's a little more noise, but nothing like the exhaust drone on some vehicles. We need to help Ed Pink. Los Angeles annexed his property for demolition and kicked him to the street, and he's been there since 1961. Lawyers might be fundraising. How did they annex it? Did they rezone something? Richard, did you ever see an OBD2 B20 intake? I don't think I have, because that would be on an Element or a CRV or something. Had a big old resonator on the plenum. So was it attached to the plenum? Anyone have a TBS faster atomic manifold I can borrow for 3D printing? The resonators a lot of times are, and especially on the 4-cylinder cars, are on the inlet air system. We see all of the factory Honda stuff has that. The Del Sol had that, and the Civic Si had that. And the later that they get, the more intricate they seem to get. Ed Pink sold the place in 2008. He doesn't own it anymore. What was the very first camshaft you ever put in an LS-based engine, if you recall? I'm pretty sure it was the 265 comp cam was probably the first aftermarket cam that I tested. Back then they only had 3, I think. Tom in the CRV, okay. Have you ever done a compression test only? We've talked about that a lot. The problem with doing that is it's really hard to make any kind of substantial change in compression without something else being affected, like the piston design. Like if you put a dome piston on it, then you have a problem with flame travel. If you change the chamber, that's changing the chamber, not just the compression, which may or may not affect power. You're changing quench, all of these things that can come into play that a guy could argue minutia about. It was attached to the plenum and had a port connector to the plenum. Yeah, it definitely affected. It definitely changes it. And if they actually have it connected to the plenum, then it can have an effect on power. Suspension bearing work isn't too bad. I just hate getting covered in grease and grime. Yeah. That's part of the joy of working on automobiles, right? So how's our poll doing? Does the ALCOVE opening in the truck intake improve power? 40% saying yes, 60% saying no. Soaking parts and purple power. We went through a lot of the purple power when we were doing the Omni too. All of the stuff kind of got that. Happy Saturday. They said something about a bus stop for the 2028 Olympics. Is that going to be in LA? Man, I'm definitely not going to want to be driving in that area. So we could do reasonable changes in compression, because like even if we did like a dome piston versus a dish piston, just the fact that one has a dish in it can change what's going on with mixture motion and stuff, and that by itself might change power. You could make an argument for that. Comp made a ton of proprietary cam lobes for us when we had Conley's Performance Plus. They've done a lot of obviously private label stuff for people. Just finished putting an LS9 in my son's 13 ZL1, which threw 2 rods. So did you put an LS9 motor in there or an LS9 camshaft in there? Had to take a crank out and have the keyway extended in order to use the LSA cam sprocket on the crank to make it wet sub. I see. Kurt, thank you. 230,000 subscribers. On my way to 1 million in 20 years. Turbo the LS9. We don't just put all the greasy parts on a Typhoon parts washer and walk away for an hour. That would be nice while it did everything. $1 million. Then I get to retire, right? I don't think that happens. I liked cutting apart the truck manifold, and the other one that I wanted to cut apart was when we did the testing on what I think was an LS6 intake manifold. I can't remember if it was an LS6 or a Dorman LS6. When we did the Engine Masters test on the effect of water methanol, and more importantly, the distribution for the water methanol, was it even in all cylinders? And there was a lot of arguments about that test also, that what we thought was happening was not actually happening, and our description of that was not accurate. And since you maybe don't know, we're not political here. Turbo LS9, that's good. Although that's not the camshaft I would pick for a turbo deal, but it will still work, because as we know about camshafts. You ever done a solid roller versus a hydraulic roller cam on an LS? No, because the number of people that would run a solid roller on an LS is, you could probably count on one hand. And the number of people relative to the people that would run hydraulic roller stuff, that's everybody basically. And then a few people would run solid rollers on dedicated race engines. I thought about grabbing an old dishwasher to use as a parts washer. Could you get enough cleaning with something like that if you use, something relatively aggressive in it and got enough temperature in it? Do you guys think that would work? That actually would be a good poll. You tear on the LD junkyard LS engine and just do ring gap. Don't you have to replace all the bolts? No, I don't. Are they torque a year old or whatever? No, we don't replace them. When we do the big bang stuff, I replace the head bolts because we put head studs in it. But we also put ported heads and a cam and intake manifold on it. So in addition to finding out what the strength of all of those bottom end pieces are, we also make lots of power when we do it. So if you have good stuff, then you can make lots of power. But all of the bottom end stuff, the main bolts and stuff, all of that stuff is just reused. Which goes to show you that at 1,500 plus horsepower, that main studs and all that are not necessary, because that's if you're using if you're using a stock bottom end, at any rate. If you're using a non-stock bottom end where those pieces are then stronger, then it's probably a good idea. I just don't know how much deflection there is in a stock non-billet cap with a main stud compared to having a billet one. And if you do use main studs, it's a really good idea to have it line honed or line bored, because it will distort it. We know that from doing bearing tests. Chrysler just announced a 1,500 horsepower supercharged 426 crate motor. That's very cool. I put outboard engines in my dishwasher. I mean, it would be better to have a second dishwasher, like in your garage or whatever, that you could wash stuff with. That would be cool. I tried the dishwasher. It worked good. Good degreaser, and the steam got a lot of the rest of the stuff was easier to scrub off afterwards. Cool. It would be better than just hosing it off, obviously. I put an exhaust manifold in the oven to cure old VHT paint. Didn't go for a big. Yeah, I have done that. I've, baked the paint in on, I think we did calipers and stuff in an oven. It's pretty smelly. Have you ever tested LS crank scrapers? I don't think I've put scrapers on an LS application. We've done them on other stuff, but I haven't ever done them on the LS just because it always had a factory windage tray on it, which seems to work fairly well. But scrapers would be better. And then a kick out oil pan also would help. Daniel, that crate motor is $60,000. What does the 1,000 horsepower GM 632 sell for? That's like 28 or something like that. Pressure washer with hot soap cleans a lot better. How can you get the pressure washer to apply soap under its high pressure thing? Mine won't do that. When I was a bachelor decades ago, I used the dishwasher as a parts cleaner using simple grain. Cool. The spray oven cleaner stuff works good. Haven't seen you do much LS7 stuff. I don't know. I've probably only ever run one or two like factory LS7s on the engine dyno, and neither one of them were mine because it's not really a wrecking yard. I have run lots of 427 stuff, but it was an aftermarket block. Need you to do some 4th gen Hemi stuff. I've only done the 5.7 that I did that belonged to the guys at Engine Masters that they let me use. And that's it, I think. Otherwise, all of the other stuff has been the earlier. Gene's here for the live feed. How's our poll doing? 64% saying no, that they don't think that opening does anything. And quite honestly, I don't have a direct answer for you. The only way for me to do that test would be to run it and then plug that and then run it again and see if it actually does anything. There is definitely plenum volume in there. I don't know if the hole would allow the resonance frequency to join. Maybe it would. I happen to agree with everybody here, and I think that it's for a NVH or like induction noise. I'm at a restaurant, so we have a low temp carbon remover spray. Oh, cool. Pressure washer with a cleaning tube setup can use additives. You put the tube in a bucket of whatever, and it sucks it into the pressure stream like a carburetor. Oh, okay. But it's not. But the stream, the high pressure stream, doesn't have the cleaning solution in it, then, right? Trying to get some ideas to keep my Ram RT to keep up with these new 5-liter 10-speed Fords. Cams go a long way on the Gen 4 stuff. Helmholtz resonance, it cancels out a frequency caused by the intake noise. Helmholtz resonance is something different than just noise. It's the resonating volume of it's the resonating frequency of the volume, and the volume is everything in the plenum, the runner, the head port, half of the cylinder when the valve is open, and then the induction system leading into that. And if you have those pressure waves that the resonating frequency generates, if you have those happen at the right time and not overlap negative frequencies, then you can improve cylinder filling. But also, there may be some noise cancellation going on there too. Stick the inlet hose in a bucket of soapy water, but they don't all work with inlet pressure. The length determines the frequency it cancels. The length of what? The wave? Not the length of the plenum. Helmholtz is a volume frequency. I also like 3D printed manifolds, like a bread box upper for a supercharged 302 GT40 lower. You mean like the old Downs Ford boxes and the CarTech ones? You don't want that because all that does is change the runner length. When we change the length of the plenum, what do we change? The answer is volume. I thought the bread box was fine for positive pressure builds. No, it does the same thing. That if you shorten the runner length, it changes where the motor makes power, and it does that NA and supercharge and turbocharge and with every application. Having tested all of those bread box kind of manifolds on every kind of engine family, we know what they do. If you shorten the runner length, it changes where the motor makes power. And when you take a GT40 lower and put a box upper on it, like whether it's the CarTech one or the Downs one or the newer version of the trick blow box, it actually has a little bit more runner length in it than those others did. You change, like I said, you change where the motor wants to make power, change the effective operating range because you've changed the reflected wave. Yeah, I wouldn't hunt for a bread box. You'd be much better off doing and especially if you're talking about a 6,000 RPM or 6,200 RPM motor, you want runner length. You're going to want, like, take a look at what all of the GT40 Explorer and Cobra manifolds did. Maybe something a little longer than those and a little bit better flowing. I think the guys that do the ported versions of those say that their stuff is working out really well. I haven't tested one of their versions. We've tested lots of older extrude hone stuff and ported versions of those, but other manifolds too. The Trick Flow stuff is really good. The Trick Flow EFI stuff, the Edelbrock RPM2 worked out really well. The Systemax worked good. Although again, even on those, they definitely make more power on the top and lose a little bit down low. You're going to kind of have to trade that. Did you ever do a test on a BTR equalizer? Way back, I tested one of their, I think it was a prototype version. It's been years and years since we did that. And the crossover point on a fast would be way, way up there. It'd already be after the fast made peak power. Can't wait till we get 3D metal printed parts. You can do some of that stuff already, right? I know that the OEMs use a lot of 3D printed stuff for prototype testing. Does the ALCOVE opening the truck intake improve power? 42% are saying yes, and 58% are saying no. I want 3D printed titanium. That would be good. "3D printed metal with laser sintering is big money." 3D printing, Dan, you're right, does take a long time. It's forever. But it's not forever relative to fabricating one. So is it worth it to do the dual plenum design on a high boost application? On what motor are you talking about, and how and where did we get to a dual plenum design? Jasco, are you talking about the paint stripper stuff? That stuff is pretty pretty caustic. How do you calculate runner length? I should put up the formula. It's very involved. And the formulas that I have are for single cylinder engines. it's better to look at dyno results and see where the thing is making power and go based off of that. So they've changed the formula for Jasco, have they? I mean, like everything else, you would almost have to, because if it worked good, just like carb cleaner and brake cleaner and all that stuff, seems to not be nearly as good. Helmholtz isn't the only thing going on in intake. No, that's true. There are actually three specific forms of charge filling associated with intake manifold design. And of all of them, the Helmholtz resonance is the least effective. If you're cleaning aluminum parts at home, go to Walmart and get the Meguiar's Chrome Wheel Cleaner. "3D print parts, even metal, are weaker than their non-printed counterparts." That's true, but we're talking about making prototype pieces so they can attest the effectiveness of the part in terms of performance, not in not in longevity. They just want to know that if they make this thing the way that they designed it and modeled it, is it actually going to do the thing that they're suspecting that it will, based on their simulations, probably. So they want to test it and put it in there and run it and go, oh yeah, it is doing that, and we can make this the way that it's currently printed. Our production will be able to do this. And so they have a piece that they know now works. And so you don't want to cast and design, cast and print or produce all of these and then machine them and then go, oh, well, that is not doing what our modeling said it was going to do. So the 3D printed is the 3D printing one, and actually dyno testing it is kind of the intermediate step between them going into production. 2.4 liter Dodge SRT4. So you have basically a small pre-plenum with a smaller slit feeding the primary. The idea is to equally disperse the air. Guys have tried that on V8 stuff to try to, essentially you're restricting the airflow to try to get the equal distribution. I don't think that that's the way to go. I think you'd be better off center feeding the 4-cylinder manifold, and maybe putting bridges or diverters in there. But you should put your manifold on there and measure and see if the thing is already equal. It might surprise you that it does pretty well. Use 3D printer to print the foam casting molds. I think a 700 horsepower turbo is that GT45 for a 5 liter. I don't know about the best one. The best one is going to be a really, really expensive one, like a dual ball bearing, some sort of Garrett thing that would be really good and super efficient at whatever that power level is and whatever the boost pressure to back pressure relationship is. And that's the other thing, that the one that makes the most power at that power level on that combination is also not going to be as responsive as you want it to be, because it's going to have a better boost pressure to back pressure relationship. But that also affects spool rate. Does the 70 millimeter on 3 will it not make 700? Or is this 700 at the tire? Good morning, Richard. 7 a.m. See, it is morning time, Chris, here in South Australia. Best turbo depends on engine cubes and RPM. If there was a best one, they would only make one. Yeah, the turbo sizing is we've gone over this a lot. You would pick the turbo for the power level that you want. And then you'd make other decisions. And those other decisions could include, okay, now how much money do I want to spend? Do I want to spend offshore 700 horsepower turbo money, or do I want to spend, Garrett, and maybe it makes a little more. But if you're only looking at making 700, is your mindset, how can I produce this? How can I solve this solution? What is the solution to this? The least expensive route? Is that the direction I'm going? Do I want to do it that way? Or do I want to make more than that? Do I want to, what am I looking at? Well, you have to look at all those variables. Looking for 700 at the tire. So a GT45 is not that then. Not looking for the most expensive, but the best. But I don't know what that means. The original VS Racing 7875, not the Gen 2 stuff, that's right in its wheelhouse. Evan Smith did a video a few months ago showing 3D print intakes from Ford Performance. I mean, I think that's the way that they would go about designing and testing one before they produce it. I mean, it just makes sense. The best is in Spool and close to max out at that power level. I'd have to go back and look and see. I would have to guesstimate what your NA power curve looks like to figure out spool rate, but I'd have to look at a few different ones to see. .4-liter 2-valve intake options. And is it worth swapping versus weight in the nose for an autocross, NPI lower and PI heads, cams and all? It'd definitely make. Are you in a position where when you're autocrossing, you're lacking power? Do you think that power is going to help you? Or do you think that better handling and better driving or better brakes or other things, more tire, are going to help you more than that? Are you in a situation where you are at full throttle thinking, man, if I only had more power? Or are you constantly having to modulate throttle already? And if you are, then more power isn't going to help you and more weight is going to hurt you. So you'd have to look at that. That's where data logging really comes in handy, so you can see at what points on the track and at different tracks where you are at wide open throttle, where you're wide open throttle, 1001, 1002, 1003, 1004, how many ever seconds it is, where you're like, you know what? There would be time gained here if my car was accelerating at a faster rate, and I still have traction, so I could do that, because that's a thing. Even if you had more power and you don't have traction, you're not going to be able to accelerate at a quicker rate if you're lacking traction already. So all of those are considerations when you're talking about doing that power swap. Junkyard Cummings, whole set turbos, cheap and reliable. I'm trying to think of maybe a 366. I don't know. I'd have to go back and look. I have so many of these maps for the ones that have maps in my head. I need to go back and look at that and see. So our poll is at 57% saying no and 43%. Chris, all of the whole sets that I've used are just oil cooled, but maybe the diesel guys have water cooled versions. There's just so many cheap offshore ones that will probably work. Whole sets for Marines that have water cooled housings. That sounds like it's going to be expensive. Suppose you could pull a Ross Chastain and use the wall instead of the front tire. A lot of autocross courses are out in the middle with no walls. That only works for one-sided turn. I guess you could use both sides, right? How do you feel about rear-mounted turbos? They work fine. If that's the best place for you to put them, then it works fine. Lots of people with turbos have grown up and because of some of the books and probably because the way that the OEMs do it, and they're doing it, a lot of people don't realize they're doing it because of emissions and light off. But a lot of these turbo books will tell you need to have the turbo as close to the exhaust valve as possible, and it's 100% not true. So the thing then becomes, okay, what is the optimum distance? And then what people need to realize is when you're talking about, or more than likely they're arguing about it, what is the optimum distance? Okay, some guys are like, it has to be as close to the exhaust valve as you can get. Others are like, it has to be, you have to have a dedicated tubular turbo equal length manifold with scavenging feeding the turbo, a la Formula One or IndyCar. And then others are saying, well, you need to have a cast iron exhaust manifold. It's got to be close. And then others are doing it back at the back. And the reality is that they all work. So they're asking the wrong question. They're asking which one of those is best. And they should be asking which one of them works for the thing that I'm trying to do. Arguing about these absolutes is just nonsense. The Duramax and later Power Strokes are water cooled. Tom Corky Bell's book had a lot of that language in there. He did, and that's one of them. And then Hughes' book and Gail Banks' stuff, and he later stated that he way overestimated the effective length of the exhaust and the charge pipes and stuff. And good for Corky for figuring that out. But again, even if you did a test and you showed that one length or one distance or whatever was optimum, it may or may not be optimum on that exact combination. And again, does that argument is it even necessary? And can you also solve your problem without even worrying about that? Yes, you can. We've run turbos like when we were doing the HP performance stuff. I remember when Jimmy put the turbos up in the front bumper because it was a modular motor deal, and they ran the exhaust and then ran pipes going from the exhaust up there and put the turbos up there. And then they went right into the intercooler. I'm like, oh, that's too far away. It's actually not. It actually works just fine. That's why guys can put them in the trunk and put them in the bed of the truck and put them everywhere else. So you get boost up to it and good things happen. And can you do the thing that you want to do with them positioned there? Quite honestly, having them there allows them to be cooled off and get cold air and all that stuff and not burn things in the engine compartment. And so there are a lot of good things to say about that too. But again, the end result is, did it do the thing that you wanted it to do? Yeah, I wanted to make 800 at the tire. I wanted to have twin turbos sitting in the back of the bed of my truck and have it look awesome and have stacker pipes. Then that's a win. Then you did what you were wanting to do. Sitting around arguing about, response rate or optimum length and all that stuff, that's just this stuff. Have you seen a quality difference between the offshore journal versus bearing turbo? I haven't ever done a direct test between those, so I don't know, and haven't ever run them in a vehicle long enough to know that there's a difference between those two. Optimize wastegate flow. That's good. There's always going to be a difference in journal versus ball bearing. What's going to be the difference? Please say spool rate. Please say spool rate. because I've yet to see that actually happen. I hear arguments about heat loss, efficiency, and turbo lag. The later I disagree with, the less heat makes more sense. There would, if you put more distance between the motor that's producing the exhaust and the turbo position, it takes longer for that. Like if you were off throttle and there's very little flow, there's more time for you to go to wide open throttle and for that exhaust energy to now at full steam to reach the turbo. That's definitely true. But again, that's not the question. The question is, does it still work for what you're trying to do? If your thing if your thing is response rate over everything else, then put it closer. But with turbo stuff, that's not always necessary, because if you're going to drag race this thing and you have remote turbos and you have the thing stall speeded and two-stepped and power braked so that you have everything that you need, that's not an issue anymore. And if you're driving around at part throttle and the turbo has some exhaust energy and you go to get back on it, maybe you don't want it to be like pinned at 20 pounds in an instant, because you don't have traction for that. Again, you don't ask yourself which one of those as an absolute is better. Ask yourself if it does the thing that you want it to do. What's the effect of back pressure after the turbo, and how loud is the turbo without a muffler? Some of that has to do with the cam timing that you're using in your turbo combination, but turbos will help. A turbo combination will have less exhaust noise than a naturally aspirated version, but some turbo things are still loud without a muffler. But you want as much exhaust flow as you can after the turbo because it helps with power. And also, this is very important because people don't understand this, the same way that they think that stock exhaust manifolds make more torque than a long tube header does, it doesn't. They make less. But also, you don't want to put back pressure in your turbo setup, in your exhaust after the turbo to help it spool. That doesn't work. Biggest difference is durability and robustness to thrust loading when running turbos that have unoptimized sizing. Generally, you're going to get more PSI out of a ball bearing. How would a ball bearing turbo change the flow rate? Because it has more impeller speed potential? See, these are all discussions that I don't ever see any data with. Like nobody has ever shown me the exact same turbo, because they always change the turbo. Well, the ball bearing one has a billet wheel, has a different hot side, and it's all of these things. And I did it on a chassis dyno, and I never could duplicate the spool rate of the one turbo, let alone the two turbos. and because that's the thing, you have to, if you're doing a test like that, if you're doing a spool rate test, you have to be really, really precise at your test regimen. And most people are not like OEM or SAE level of testing. They don't do that. They don't make it do exactly the same thing back to back under the same test without any changes. They're not even as good enough to do that, let alone then to judge it when they do the new thing. And they also want a result. They want the ball bearing turbo because they spent more money on it and because they want it to be cool and tell their friends, oh yeah, it comes up. I've had people tell me, oh yeah, it comes up 500 RPM quicker. There's no way that bearings do that. There isn't that much drag when you have an oil barrier between the bearings and the thing that's spinning. There's no way that you have that kind of drag. It's not possible. You do not have 500 RPM worth of spool rate drag difference between those two. That's not a thing. So they change something else. But the problem is that goes out onto the internet and they say, oh yeah, ball bearings spool 500 RPM quicker. No, they changed the turbo. The turbo is different. If they change the spool rate, it's because they added a lot more heat. or because they changed the turbo and now it has a tighter AR or it's smaller or the turbo configuration is different. Oh, and we also changed the boost level. Okay. Larry, you're here. And we have a poll up already for you, so just do it. Where does the theory that back pressure helps torque come from? I don't know. I don't really understand that. I've never found that to be true in any of my 4-stroke builds. It doesn't. Back pressure is never good. Back pressure between the engine and the turbo obviously is going to be a byproduct or a cause, depending on which side of that argument you're on, for spool rate. So I can see the understanding there. But after the turbo, you every time I've taken exhaust after the turbo off or improved it, it improves spool rate and the turbo sounds better. It's more excited. The whole motor program works better. I've never had better spool rate from having back pressure after the turbo. Having back pressure after the turbo also changes back pressure before the turbo. Billet wheels that claim more power and faster spool oftentimes have designs that don't match the OEM compressor. That's the thing. That's also the thing is the billet wheel is another deal. Billet versus cast wheel. Okay, so what did we change? Did you just make a billet version that's identical to the cast version? Is it the same weight? Probably not. Is it the same impeller design? Probably not. So you changed multiple things. So the billet thing is just probably going to be a strength thing, and that's probably good. And then, like I said, normally when they do a billet version of some of their cast wheel, they've also changed the wheel design, hopefully to the plus side, to improve spool rate or total boost possibility or whatever they're doing in their design criteria to change the wheel. Large stationary turbine engines use journal bearings. So like on industrial engines? If you had a separate oil tank feeding the turbo, so you're gonna have a turbo and you're gonna have a separate tank and a separate pump, all of that feeding the turbo. Have you gone over why the ALCOVE is in the intake? Yeah, the general consensus is that we think it's for noise reduction. Isn't back pressure like short headers versus long headers where one gets better low end? No. We just went over that. Short headers never make more power down low than a long header does. Shorty headers and stock exhaust manifolds do not have, well, they actually might have better flow characteristics depending on what size you made the short headers. If you put big tube short headers, they may, if you flowed them on a flow bench, they might actually flow more than a long tube header. They just won't make more power because they don't offer any scavenging. And the scavenging effect is what changes the power, not back pressure. I would think the ALCOVE acts like a muffler for standing waves, but it's only attached. It's completely enclosed, and it's only attached by a tiny little hole to the inlet side of the main tube. You do know that even IndyCar and F1 impellers are cast and not billet. What happens if you spin the turbo too fast? Cavitation and catastrophic failure are both things that can happen. It's like trying to spin a propeller in the water too fast. You're spinning it so fast that it actually doesn't have time to grab the water and process the water through. Same thing happens with an impeller. It's not actually grabbing the air. It's just spinning and chopping away, and the air never gets into it because it's spinning so fast. It's like hitting if you can think about it, it just makes a solid piece that the air has to hit, and it doesn't ever allow the air to get in, and so nothing happens. It's not processing any air. Back pressure and intake restriction both add to pumping losses. Yep. I think what gets misstarted is badly tuned cars and trucks, whether it's carb or EFI. That also happens, that they put something on and see a gain or a loss and then go, hey, look, I just tested it. That has to be gospel. Yeah. But you put it on and now your air fuel is 15-1 because the thing that you put on wants to make more power and you aren't giving it enough fuel. On motorcycles, you can run open headers and lose power versus having an exhaust mounted. You would mean having a collector extension on there. Isn't that because of back pressure? It's not back pressure. Goldar, I'm curious, why are you wanting to have a separate pump? And you wouldn't have to heat it up. Going through the turbo would eventually heat the oil up. Richard, watching from New Zealand. So not from down under, down above. Where is New Zealand above Australia or is it below? I don't. I should really know that. So bad that I don't know where that is. Oh, it's south. Oh, it is south. Okay. Southwest, right? I don't know why was I thinking of Greenland? After doing some research, I have concluded, or I have heard, that compressor inducer inner diameter is a good rough indicator of airflow potential. I think that that's probably true because that's the smallest opening for the airflow. So I think that would be accurate. Christchurch, New Zealand. Very cool. Did they film Lord of the Rings there? Have you ever tested the longevity of GT45 turbos from eBay? The only longevity test I've done is I've been running the same GT45 turbo for probably 10 years. Now it's not running on a car and driving around, but we run it, and then throw it on the ground. Then run it, and throw it on the ground. It gets zero love, because it's $163 turbo or whatever. So the ones that I have all, or the one that I have, I think I have 2 or 3 of them now, because we got some from Max Speeding also. But the ones that I have and the CX Racing 76 millimeter turbos from the original Big Bang back in 2010 are all still working. Fascist Pen, I came later talking about the resonance chamber before the throttle body. No, if you look at the thumbnail, you'll see there's an ALCOVE chamber inside the truck intake manifold that's after the truck intake manifold has a tube inside of it, and the tube has an end at it, and the air has to go in and make an upper left hand turn basically. Well, at the end of that tube, where the airflow has to make a turn, there's a small opening, and behind that small opening is an enclosure, an enclosed alcove that just has a connection through that small tube. So the question was, what is that thing for? Yeah, just like Greenland, but in the other hemisphere. Not the residence chamber before the throttle body. We know what that does. Once the air compressor inlet gets to sonic velocity, no more air can be drawn in. Would be better to have two GT45 turbos or a giant 90 millimeter. You can do the same thing with either one of them. If you need to size your turbo or turbos for the combination of, the first thing I like to look at is power level. So size it for the power level that you want, and then size it for the next thing to look at might be response rate. So in sizing it for 1,000 horsepower, you would size it so it can't do much more than 1,000 horsepower, because that's one way to get a pretty good idea to improve the response rate. And I have to figure out how to extend my T3 45 trim compressor map to handle 3-bar because I'm off the map. So you're going up. You can reach the surge line going that direction too, because a lot of the turbos are not designed to run high pressure ratios. I don't know which one that is and whether or not it has a map, but idea for future tests: spool gates. Are you talking about quick spool valves? Draw through turbo positive seal still a thing. It is. You need a carbon seal for draw through applications because of the fuel. We're just going to run one anyway, though. Dean, you're in Dundon, and Richard Holder is world famous here. So now you're just making stuff up. I'm excited to see a future test of the ALCOVE plug versus open. I've never done that, but I do have lots of truck manifolds on stuff, and including on that L33. The other test that I want to do with the L33 is I haven't ever put a fast manifold on one of them, and I want to put a fast manifold on it, and I want to put maybe the cam that's in it right now, maybe that red hot cam, which is not, I like the hot rod cam better actually for that application, but the red hot cam, and then a fast 102 with a 102 throttle body, and then a radius entry on the throttle body, and then the inch and 7/8 headers. And I want to see how close to 500 we can get with the stock heads on it. I don't know how close we'll get. I think it's going to be less than 500. I think it's going to be more like 480 or something. Big guy, your 340 horsepower motor will be doubled. The power output would be doubled at 15 pounds. But in reality, you could just do that with one GT45, and two GT45s are going to be really soft on spool on that motor, because that motor doesn't need two of those. It just needs one of them. And if you want to make more power than 750 horsepower, or whatever, then put one S475 or one 7875 Gen 2, that kind of size turbo. I'm half an hour to Hobbiton. Nice. I don't know if you saw my last post, but I have a 2000 Silverado 4.1, 4.8 D1 SC. That's good. Steven, only your tuner will know that. If he continued the tune and went up in scale at the higher boost levels, it should be fine. And also on the timing map, if he went up in scale again, and by up, I mean he started taking timing away with higher boost levels, then it should be okay. But you need an air fuel meter on there to know what it's doing. Like, it'd be a good idea to run it on the chassis dyno to make sure that it's doing it. You're going to go from a 3 to 348. I don't know, 2.5 pounds or something. Maybe 3 pounds more, depending on what RPM you're running it to. The higher the RPM you're running it to, the more you're going to gain in boost. Would a thinner oil be required in such a situation? You're going to, what pump are you going to use to circulate this? Most of those are fed at engine oil pressure. So it's going to vary with speed. So it's going to range from 30 or 40 PSI up to 60 or 80 PSI. Do you have a separate pump that's going to do that? And you don't need a thinner oil. I guess you could. I don't know. I honestly don't know how quickly that's going to get up to temperature. And then also you could vary that with your feed orifice. And oh yeah, Dan, I think Dan mentioned what your bearings are and stuff in the turbo. Or just let him heal. That's cool. Bro, you just let him heal? I hit him 100. Man, just let him heal. Yeah, right, Dean. Should twin GT45s with 2 quick spool valves spool as quick as a single GT45 on the same motor? I don't know. I've never run a quick spool valve on the engine dyno. Do long tubes have more of an effect on low compression ratio versus high compression ratio? The compression ratio is not going to have an effect on the effectiveness of long tube headers. The compression ratio is just going to affect power everywhere. It's like for honor in that way. I'm past 154,000 turbine speed. So you would also be past 154,000 impeller speed, because I think that they have to go the same speed. Okay, we're going to close out our poll here. 52% saying no, that they don't think that improves power. I'm curious to see if it would have any effect. It might. I'll bet it has as much effect as flipping the pistons. It's the blue one. Dean, you won the poll? Winner, winner, chicken dinner. Okay, guys, it's the weekend. You need to go out and get your stuff done. And if you haven't, please watch the video that I just posted, the 274 cam, the one cam to rule them all. And then when I say 274 cam, you just reach over and close your eyes and grab any other cam from the shelf and plug it in, and that cam does the same thing. Thank you guys all. Have a good weekend. I will see you tonight. Pew, pew, pew. I need to go play Battlefront.